For lesson 1.11, ready, set, go, we are looking at wrapping things up and tying it all together. Something we haven't really talked about at all is the similarities between a linear equation and an arithmetic sequence. The similarity is that it is constantly changing, in that it will go up by 5 units or 2.2 units or whatever it is. It's going to go up or down by a consistent rate. That's the same for a linear equation and an arithmetic sequence. One of the differences would be that an arithmetic sequence is typically going in steps. So step 1, step 2, step 3, or figure 1, figure 2, figure 3. Whereas a linear equation, I can plug in 5.2 and get something out in return. On the contrary, you can't take step 5.2. So we have one of the differences being that arithmetic is something called a discrete function, and linear is called a continuous function. A discrete is at any moment in time on some whole numbers, on some integers. Step 1, step 2, step 3, step 4. So in those specific or discrete moments, whereas linear, I can take any number, any input, and plug it in, I should get an output. For the set portion, for number 2, you've got your recursive equation, explicit equation, context, and graph that you need to be able to complete. So I have the table, which is a lot of information that I have already. So to create the recursive equation, I need to define where I begin, which is 8, and how I move. So we're going to move by adding 8 each next step. For the explicit equation, very similar. What is the first step? 8 plus, we are moving a common difference of 8 units each step of the way. Create a context, that would be for you, but you could write something in there, and I'm not going to write it down, but you could write something in there about how you are buying lunch every day or dinner every day, and you need to figure out how much it's going to cost you each step of the way, knowing each meal is a flat fee of $8. So some sort of context would be written in here. To graph it, we can go 1, 2, 3, and 4, and it's going to get really big really quick. So what we can do is we can actually go 4, 8, 12, 16, 20, 24, 28, 32, 36. So 4, 8, 12, 16, 20, 24, 28, 32, 36. And 1 would be at 8, 2 would be at 16, 3 would be at 24, 4 would be at 32, and you notice that it's in a straight line. But because this is a discrete function, because we are giving a certain number of days and a total number of dollars, or a total cost, we'll leave them as those points on the graph that you see. For number 4, you have your explicit equation and need to complete the rest of it. So there's a lot of stuff going on here. Let's take a little bit of a different approach, and we're going to start the table before doing anything else. So if I plug in a 1, into this equation, I would end up getting 1 minus 1 is 0, 0 times 5 is 0, 0 plus 4 is 4. If I plug in a 2, 2 minus 1 is 1, 1 times 5 is 5, 5 plus 4 is 9. If I plug in a 3, 3 minus 1 is 2, 2 times 5 is 10, 10 plus 4 is 14. I plug in a 4. 4 minus 1 is 3. 3 times 5 is 15. 15 plus 4 is 19. And what you should see is that each step of the way, we are adding 5. So for our recursive equation, first define your first step and tell me how it moves. For graphing it, similar process as before. So I'm going to have a graph that goes off the grid, but we'll have our 1, 2, 3, and 4. And we're gonna go up by 4 again. So 4, 8, 12, 16, 20. So step 1, you have 4. Step 2, not quite 8, a little bit more. Step 3 is 14, halfway. Step 4 is 19, all the way, almost up. And so you notice that we've got pretty much, again, a straight line, and we should because it's an arithmetic sequence. Creating that context, giving yourself a story. I started off with 4 pencils, and every day I collected 5 more pencils. There you go. For number 6 and 7 and 8, we are trying to write the explicit equation given the recursive equation. So we have everything we need, again. Now it's a matter of understanding what's happening. So to remember correctly, our explicit equation will be the first output plus the common difference times n minus 1. Okay. Here we go. For number 6, the f of n equals, our first term is 8, our common difference is minus 2, which is right there, and you're done. That's it. For number 8, f of n equals, our first term is 5 over 3, our common difference is 1, and you are done. Hopefully this helps. Reach out with any questions you might have.